The other part, we are going to see the nature of the data that we are going to deal with within the GIS. And there are two main parts, which is basically the spatial data and the attribute data. And as the name suggests, spatial data is data that has the location, and attribute is the description of the data itself. Of course, this will be limited to a specific sector, but the different data type. We shall see that, and that is basically tailored to the approach that we are going to work with. We have spatial data, which is data showing you the different occurrence or different features within an area. This data could be either collected data, could be the usual XY coordinate data. We could have satellite imagery, we could have drone image. All this is spatial data. And when we look at spatial data, we have three key geometry types, and these are points, lines, and polygons. And we have the fourth one, which is basically the raster format, and this is what we are calling a surface. So you're going to see all this and how it works. In terms of the formats, we'll be able to use these different geometry types in different applications. So remember, you can work with 10 layers, you can work with 5 layers, you can work with 20 layers and above. This depends on the project that you are carrying on. We have an example of image data, which is a form of data we refer to as raster. We are going to see how to reference the image data. It could be satellite data, it could be drone image. We are going to see how we use it to basically come up with what we call vector data. We are going to see that in details. We have another key element, which is called attribute data. And attribute data, as the word suggests, is a description or a descriptive type of information about elements or about features happening or occurring somewhere. So we will be able to see this. It's a very wide topic, but also very interesting. It enables us to have a lot of power in our hands, in terms of carrying out analysis processes within a GIS. And then we have two main data models. I've mentioned in the previous slides, where we have vector, what we are calling lines, points, and polygons. Those are basically vector data models. And then we have the surface, which is the raster model. We are going to see what the raster contains in the future slides. For now, if you look at the vector data models, think of the maps that you used to work in school, where you head down a road and someone would ask you what's the main economic activity of this place. You would have different elements, such as schools, such as roads, such as rivers. These are basically different elements or different feature types. For example, the way we describe a house is not the way you describe a road, and it's not the same way we describe a lake. So these are different data or geometry types and data types, which we are going to handle within our course. The other one is the raster, where we represent data as continuous grids. We are able to see how those works, and there's another term that we are going to also use a lot, which is called the pixels. In this concept, I want to introduce or to basically touch on a very simplistic a concept, whereby it's the issue of satellites or drones, how they are able to perceive the image of planet Earth from above there. They are able to sensor different elements on the ground, and they'll produce images with different reflectances, displaying or illustrating different features. So the way a house would reflect is not the same way the ground will reflect. It's not the same way lake or water will reflect. So it will depend with how the kind of sensor you are using and the kind of perception or recording you are dealing with, and we will be able to also see that and the outputs. In this course, we are not going to basically do the actual recording. We are going to see the outputs that these processes produce. So we have raster dataset. We use to see how this works. And one of the other elements that we need also to consider a lot is the issue of characteristics of data. So we know that we are dealing with spatial data, which mostly answers the question of where. Okay? But when we carry out the different analysis, we are able to answer questions as how or why. So this is from the analysis, from the data that we have. But in some cases, for the person or the people who have worked on data before, they could simplify your work by just giving or illustrating what you call metadata in the different files that you get. So metadata could simply be put as data about the data or a description about data, and we are able to see this from the different data sources that we acquire. Metadata is a key element in GIS because it helps to describe what you are working with, and from a glance you can understand if this data fits your criteria or not. As I mentioned, these are the different file formats. You are going to see them, and we are going to look at the different elements. So when you talk of element that's vector, what is vector file? What does it include? Actually, in this course or in the GIS industry, most of the times when someone talks of a shapefile, they mean the vector files. So shapefile has become so common such that it has almost become the key or the standard name within the GIS industry, and we'll be able to see that and how it's structured. You see the kind of file format that it includes, what is included there, and how it looks like. Then we have the raster, which is basically think of the images on your phone. Those are raster images. You can use those to do something. Most of our images nowadays are geotagged. So you can actually load an image on your GIS because it has the location element, and you can continue using it within your GIS environment. So we have other formats such as guys coming from the construction industry. That is guys who use a lot of CAD software, a lot of KML and all that.